Polytec, advancing measurements by light. Non-contact vibration measurement on rotating objects. Introducing the optical derotator. Characterizing the dynamic behavior of rotating parts is essential to high-performance designs, extended durability and minimal acoustic noise. Traditionally, measurements of deflection, shapes and resonances on rotating parts were extremely difficult and required special effort or were limited to extrapolation from stationary data. Polytec scanning vibrometers have revolutionized measurements on stationary parts. Now the optical derotator brings the scanning vibrometer revolution to rotating parts, characterizing rotating parts under real operating conditions with the same ease and flexibility as stationary parts. Basically, the optical derotator maps the part's rotating coordinate system into a stationary coordinate system. Therefore, an observer looking through the derotator at the rotating part sees a stationary object. The derotator works by tracking the part's rotation and locking its rotational speed to the parts. An encoder signal provides the rotation speed and permits precise closed-loop control of a rotating Dover prism, used by the derotator to optically compensate for the part's rotation. Simply put, the vibrometer sees a stationary part that can easily be scanned by the laser probe. There are four key components which enable derotated optical vibration measurements: the rotation unit with the Dover prism and the precision drive, the scan head enabling full field measurements, a single point laser vibrometer providing a phase reference for the scanning procedure, and an adjustable fixture that provides 4 degrees of freedom for aligning the rotating axis. The alignment procedure is simple and straightforward. First, the angles between the rotating axis of the object and the derotator are adjusted. If the alignment is okay, the first order of rotation is at a minimum, giving a clear signal to the operator. Second, the offsets are minimized. Here, the indicator is the video image displayed on the monitor. The alignment is okay when the video image is stable and without blur. Once perfectly aligned, the dynamic behavior is characterized by a run-up measurement. The derotator tracks rotations up to 24,000 RPM and angular accelerations up to 700 RPM per second. While the test part speed ramps up, a time trace is acquired by the data management system. The data is post-processed by the VSI Rotate order analysis software. Resonances excited by the orders of rotation can clearly be seen. Stiffening effects manifest as curved eigenfrequency traces. Let's now look closely at one of the resonances and see the behavior of the deflection shapes, a job that is done by scanning vibrometry. The rotation is now locked to the identified speed. A scan grid defines the measurement locations, which can have an arbitrary density or be derived from finite element models. The vibrometer's laser beam automatically scans the whole grid and makes a vibration measurement at each point. The outer laser circle is generated by the second laser, acting as a phase reference. While scanning, the signal-to-noise ratio is automatically monitored at each measurement point and color-coded to indicate the level of data quality. When the scan is complete, the deflection shape is visualized in a 3D animation and can be compared with simulation results. This two-step process consisting of order analysis and full field scanning is suitable for both verification of a numeric simulation and for troubleshooting in case of insufficient performance. The derotator gives immediate insight in the dynamic behavior of rotating machinery without instrumenting the part with special transducers or using telemetry. The scanning laser vibrometer yields excellent data quality and a high measurement density due to zero mass loading and a small focus spot size. This novel solution provides reliable input data to simulations and for the verification of finite element models. Benefit from these critical advantages today. Polytec, advancing measurements by light.